Hello all, welcome to the new problem of Leetcode. Today we are going to look at the problem 662. It's another medium problem based on the binary. So in this binary, what we need to do is for a given binary, return the maximum width of the given tree. Now how do you calculate the maximum width here? So based on the description, if we read this, so let's say this is a tree here, for example given. So in this trees, if you go down to the tree, so depth is 0 here, 1 and 2. In this tree we can see there are 3 nodes, but let's say if there is another node here, because for the child 2 there is no left node, only the right node is present, then the total width have been, so total number of nodes will be on this particular depth will be 5, 3 and then some number here, let's say x and then 9, so total would have been 4. So that's what it is asking. So if you are given root, given tree, so what is the depth for a particular depth? So what is the for the lowest depth, what is the width of the tree? But one catch is here. So let's say for this example, so we have 1, 3 and 2 and then 5. In this example the last node is 5, but there is no another node present on in this tree, so only the maximum depth will be calculated based on this particular node, the 3 and 2. We cannot use 5 to calculate the width because there is no right node present in the tree. Let's say there is something here, then we would have definitely considered, but in this example only 5, just we'll have to node 5, just use the previous one as the maximum width. Now how do we solve this problem? Let's look at example. So one thing we need to see is how do we identify what is the position of the node. So first of all we need to see what is the depth. So for example, let's say this root d, first one, let's say depth is equal to 0, and this one let's say depth equals to 1, and then this one let's say depth equals to 2. So as soon as we go down, depth will increase. So we start with 0 here and then 1 and then 2. Okay, now we know that we have reached to the maximum depth. One logic what we need to put is, in order to identify the first column position and the last column position. For example, let's say this one is 0 and this one first column is 0 and then 1. Here first column is 0, second column is this 1, third column is missing because there is no left child here, so there is no left child. So let's say if there is something, it would have been 2 and then this is 3. So 0, 1, 2, 3. So this is the order. In case something else is there, let's say this is 7 and this is 12, then again we'll have to calculate, this is null, then again these two null, and then this one null. Then in this case what would have been depth? So 0, 1 and this one 2, 2, and for this one is 3, for this one is 4, for this one is 5. Okay, so starting from these two, how many nodes are there? 1, 2, 3, 4, 5, 6. But in this case we don't have it, so we just forgot all these things. We just keep what is given in the example. So I was just trying to explain in case if there are further nodes, what could have done. Okay, so again, so this is for 0, 1, for this null value 2, and then this is 3. So total is 4 nodes. So that means, so the minimum here is 0 and maximum here is 3, right? So when we calculate the difference, so max is 3 minus 0, that is 0. But since we are starting with 0, so we will add plus 1, that is, so this is the width of the In order to solve this problem, what we are going to do is we will create a hash map, basically a dictionary in Python. So in the dictionary, at each level we are going to store the number of nodes. Let's say 0th level node is only 0. So for basically column position, we store the column position. And the first level, the column position is 0 and 1. And the second level, column position is 0, 1, as I explained, 2 and 3. In this way, we store the column position for each depth. Then we keep repeating process if there are further depths, right? And then once we have this particular dictionary, in this dictionary we'll try to find out what is the minimum and maximum. So in this case, 0 is going to be always 0. Here the difference is 1, and then here the difference is 3. So wherever we find the maximum difference, that we will return as our result. That is going to be result. So we have to just keep track of the depth, and then we keep track of this particular dictionary, where we store each depth, what is the minimum and maximum number of column present. So at this depth, this is 0, and this at particular depth level 1, this is 1. At depth 1 it is 0 and 1, and depth 2 it is 0, 1, 2, 3. So there are 4 nodes. And then finally we'll iterate on this particular something weird, but yes. So we'll iterate on this particular dictionary, and then we'll figure out what is the maximum difference, and then we will return this. So let's go back and look at the code. So as I mentioned, so I'm initializing a default dictionary for now, which is going to be empty. So one thing I didn't tell you, how to calculate the column position. So in order to calculate the left column position, we'll multiply column into 2. So what is a column? We'll start with 0. Let's say this is 0. So this position will be 0 into 2 is going to be 0. This position is 0 into 2 plus 1. So this is 1. Same way we keep doing this for each node in the tree. And then finally for each depth, I'll add the column position. For example, for depth 1, this particular depth, I'll add 0, 1, because 0 is represented by 3, and then for 1 we have 2, and then we'll update the dictionary. So in this way we'll keep updating the dictionary, and then we'll traverse the whole tree. So since we are traversing each node, so we will have the time complexity of O(n). And then finally from the dictionary, so I'm going to find out what is the minimum and maximum value. So for this particular depth, minimum is 0, maximum is 3, and then I'll subtract. I'll take the difference, and if the difference is greater than my result, initially I initialize as 0, then I'll store that as a result. And then I mentioned, since we are starting with 0, so we'll just do a +1 to the result, and then that's it. I run this program. Okay, all test cases pass, and then submit. Okay, it works, not too bad. Alright, thank you everyone, thanks for watching.